All right. What I was saying was, okay, this is Kubernetes part 2. If you have not done Kubernetes part 1, this is going to be hard. Tomorrow will be part 3. And they're all one after the other. So make sure if you skipped any one of these classes, which is last Saturday or Sunday, most probably you should just drop off at some point. Feel free to try out for a while and see if you're able to understand things. But we're going very sequentially, which means if you don't know any one of these things, these are things that we did already last week. That includes clusters, nodes, pods, deployments, replica sets, and services. I'm missing one thing here: services. If you don't know any one of these, or if some of these you've never heard of, then feel free to drop off. If you do know all of them, you were here last week, then we're good to go. What we're doing today includes namespaces in Kubernetes, ingresses and ingress controllers, config maps and secrets. This is what we're doing today. What we're doing tomorrow is certificate management. How can you add HTTPS to your Kubernetes deployed applications? Volumes and persistent volumes. How can you create databases, which is something you shouldn't do ideally, but good thing for us to know. How do you use volumes and more specifically persistent volumes to persist data in Kubernetes? And lastly, resource management. How do you restrict certain pods to only be having 8 GB of memory or one CPU that they can use at a time? This will be followed by a bunch of offline videos, or if you don't get the time, then of course this will be live next week, but I don't want to stretch Kubernetes for too long. So horizontal pod autoscaling, node autoscaling, and a few labs on real code bases. Most probably this lab is going to be on the Lead Code Codeforces project that has happened on YouTube. It's a decent project. It has a bunch of microservices. So Kubernetes, writing the manifest files for it is going to be a lab/assignment. Most of the times when you do DevOps things, they're called labs. This will also come next week, and then we'll see if we have to do more in Kubernetes, but I think this should be a great starting point or even ending point for Kubernetes. Again, to recap, if you don't know any one of these, feel free to drop off. I will be recapping this today, but not too much in depth. The reason we'll be recapping this is because from services is when we will move on to ingresses. The first thing we have to learn for today. What is the first thing we're learning today? We're learning ingresses and ingress controller. To understand ingress and ingress controller, we first need to understand what are some downsides of using services. That is why we'll first be going through everything from top to bottom, eventually reaching services, and then move on to ingresses. Let's get right into it. Let's recap everything we've done until now. The slides are here for last week. Feel free to go through them. Feel free to go through the videos. The first jargon we learned about last week was something called a cluster. Now, when you're using Kubernetes, the first thing you do, if you ever open any cloud provider like Amazon, GCP, or even if you're working locally on your machine, the first thing you have to do is you have to create a Kubernetes cluster. What is a cluster? It's just a bunch of machines that you start. If I go over to a cloud provider like Vultr, which is very similar to AWS, you will see a section over here called Kubernetes. AWS has a similar section called EKS. Google Cloud has a similar section. DigitalOcean has a similar section. And when you go here, the first thing it tells you to do is add a cluster. It doesn't say start a machine. It says start a cluster of machines. Start many machines. And once you go through the steps over here, you eventually get a full-blown cluster to deal with. I am going to create one today on the internet. You don't have to. You can start it locally if need be. Or if you want, go to Vultr with me. They have some $100 of credit, and feel free to create one with me really quickly. I'm going to name this week 28. I'm going to select Mumbai as the location. I'm going to select only 2 nodes just to save some money for me. And I'm going to name this node pool as week 27 or 28. It tells me you will be charged $90 a month because I'm starting $245 per month instances. If I click on deploy, it starts a Kubernetes cluster. It is not start one machine. It starts 2 machines for me. If needed, I can add more machines in the future. That's what a Kubernetes cluster is. I just started one on the internet. Slowly we'll build up and try to deploy an application here. Next jargon to learn about is nodes. Name is pretty self-explanatory. When I created this Kubernetes cluster, I selected 2 amount of nodes. If I go to my compute section over here, which means the machines that I have, you will see 2 machines are now starting for me. Each one of them is called a node. A cluster has multiple nodes, and we just started 2. Pods are the first slightly hard to understand concept that we understood. Okay, every cluster has multiple nodes, and the final application that you deploy, let's say I deploy my Express server over here, will be deployed in a pod. A pod is the smallest execution unit inside Kubernetes. A cluster has various nodes. A node can have various pods, and a pod can have multiple containers inside it. I can start a backend container. I can also start a front-end container inside my Kubernetes pod that I'm starting. This is the first uphill battle to understand what a pod is. In the next slide, we will also connect to our cluster and try to start some pods in there. Next thing we understood was replica sets. As the name suggests, if you want to start multiple pods of the same type, if I want to scale my application, if I want to start 3 pods running my backend code, I can create a replica set. Replicas mean duplicates. A replica set means I want to create a set of duplicate pods. And if I set the replica number to be 3 pods start in my Kubernetes cluster. They might start on different nodes. They might start on the same node, but I see 3 pods running. If I change this number down to 1, the replica set is able to delete 2 of my pods and only a single pod works. If I increase this to 4, it will take care of starting 4 pods for me. So it makes our life easier as the developer. Okay, I just have to change a number over here. The replica set controller takes care of changing the number of actual pods. And the last thing we learned about, second last thing we learned about was deployments. Okay, rather than directly creating a replica set, create a deployment. I am deploying my backend application. Here, mention I want 3 replicas, and this deployment will create a replica set, which in turn will create multiple pods. I repeat, just create a deployment and set replicas to be 3 here. This will create a replica set. Once the replica set is created, this will create the pods. Hakira, then what is the difference between deployment and replicas set? The answer is that whenever you do a update, whenever your backend application updates, someone pushes some code on GitHub, the deployment will create a fresh replica set. It will say old one also stay there. It will create a new one, and the new one will now start 1 pod to begin with. The deployment will check, is this pod healthy? If this pod is healthy, then it will downscale these replicas down to 2, increase the number of replicas for the new deployment. If the second pod is healthy, then it will slowly downscale this. It will let you do rolling updates. Why do you use deployments? Because deployments let you do rolling updates. They make sure that if you have deployed a new version, they will first create a replica set with the new version. Only if the pods that are starting are healthy, will it slowly downscale this replica set, upscale the new replica set. So replicas let you orchestrate pods. Deployments let you orchestrate replica sets. Lastly, the thing that we understood was services, which is here until this point, until deployments, you can start a bunch of pods. You have many pods running your backend code, but you can't visit them. You can't send an HTTP request on www.google.com that will reach this specific pod, or whatever domain name you might have, www.ankitjain.com. To make sure that request reaches here is where services come into the picture. When you create a service, it exposes your pods over the internet. You can start to hit one of your node's IPs on a certain port, and this request will route to one of your pods. This is how you can actually access your pods. Services were of 3 types, if you remember. Cluster IP service, which was used for internal communication. If there are these 3 pods that I want a 4th pod in a different node to talk to them, I can create a service. The 4th pod can talk to this service, which can load amongst 3 pods. If I want to do only internal communication, which we won't for a while, we will do it when we bring in the database. But before that, we don't have to worry about internal communication. When I want to do internal communication like this is when you create a cluster IP type of service. I repeat, if I have two nodes, node number 1, node number 2 in my Kubernetes cluster, and let's say I have 3 backend pods running over here, 2 over here, 1 over here, okay? 3 backend pods running, and I started a 4th pod called, front end, let's say, or, backend 2. I can create a cluster IP service. I can create a service of type cluster IP. The name itself says cluster IP, an IP that is accessible inside my Kubernetes cluster. This backend can send a request to this cluster IP, which can forward it to either this guy or this guy or this guy, load balance the load. This backend can also directly talk to one of the pods, but that's just a little hard for it to know, what is the IP of pod number 1? What if pod number 1 dies and then, restarts, it gets a new IP. And hence it's just easier. Okay, you create a cluster IP service so that if an internal pod wants to talk to any one of these pods, it talks to this guy, which forwards the request between one of these 3. As long as you don't want this exposed over the internet, a cluster IP service is good enough. But if you want to expose it over the internet, I don't have a backend too. I have real users who want to send a request to some IP, let's say 92.1.33.5 or some URL, ankit.com, let's say. Then you need to create what's called a cluster IP service. I repeat, what is the type of, not cluster IP, node port service. What is the type of service that you need to create now? A node ka port. Both of these nodes have various ports that they can expose. Just like my machine can, I can go to localhost :3000. This 3000 has something running on my machine, let's say. And similarly, on this node, you can expose a port so that the person can go to, some URL that looks like this, 92.1.33.2 :30,007. Unfortunately, this port range needs to be really big, from 30,000 to some very big number if you want to use node port. And this is also not the best way to expose your applications, because you're exposing the IP of your node. You're literally saying, 92.133, this IP, you are telling to your end user. So your cluster is no longer hidden. Even though node port is a decent service, a decent way to expose your application, you probably don't want to expose it like this. Then how do we expose it, Harkirat? Using the 3rd type, the load balancer service. The load balancer service creates a load balancer outside your Kubernetes cluster. It does something like this. This is your cluster which has multiple nodes, multiple pods, whatever. I will create a load balancer outside, and you can send a request to this load balancer. It will forward the request to the pods. The end user never knows the IP of my nodes. They only know the IP of my load balancer. That is why the ideal way to build services, the ideal way to expose your pods is load balancers, and load balancers are great. If you want to expose your application without any complications, if you have a simple use case, a single application, create a service which is of type load balancer, expose your application, good to go. There are some downsides to this, which is why ingresses come into the picture. But before we get there, let's quickly bootstrap an application. You can do this locally as well. We have done this locally last week. You can do this on Vultr as well. For the sake of this video, I'm going to do it myself. Just look at it, breathe it in, and after the class, maybe try it yourself. There are too many debugging back and forths that happen when, we do it together. If you want to, though, if you have the speed, feel free to, do it along with me as well. This is how we run it locally. This is how you run it on a cloud provider. I am going through slide number 4, which is how you run it on a cloud provider. But if you want to run it locally, you can follow these as well. If you remember from last week though, if you want to create a load balancer service, you cannot run it locally. You have to start it on a cloud provider. Only clouds have this concept of external load balancers that we need to start. When you start it locally, you can still work around and create a load balancer, but it won't happen out of the box for you. So ideally, if you are start trying this as well, try this on, doesn't matter, Vultr or Google Cloud or some other cloud provider. How to run it on a cloud provider? Number one, create a cluster. I've already done this. Number two, download the credentials file and replace your local Kubernetes configuration with it. Whenever you create a Kubernetes cluster, irrespective of where you create it, you can download a configuration for it. What is the configuration? It just contains your endpoint of the Kubernetes API server. It contains the passwords that you can use to connect to it. It's your admin credentials. I repeat, this is your admin credentials to connect to this cluster right here. If I lose this file, if someone else gets this configuration, they can start pods in my cluster. So you want to keep it very safe, and you want to replace your local Kubernetes config with it. Where is the local Kubernetes config kept? Your root folder /.kube/config. So let me open my terminal and delete my old kube config and copy over my new kube config. Opening it in Vim, I to enter insert mode and then pasting the contents of it from Visual Studio Code. Copying this, pasting it, and then exiting out. Now, if I run kubectl, which again is something we did last week, it's a command line that lets you talk to Kubernetes. If I run kubectl get nodes, it shows me you have 2 nodes running, Harkirat. They were started 10 minutes ago. These are my Vultr nodes that I just started 10 minutes ago. These 2 nodes that you saw in the compute section. Now I can, for sure I know, okay, my thing is running, my kubectl is connected to my Vultr Kubernetes cluster. Let me start some pods really quickly. Let me expose a simple application. So we are able to recap everything from last week. What are the things that we learned about? We learned about clusters, nodes, pods, but what do you really need if you want to start a full stack application? If you have a cluster, it will automatically create nodes. And if you have a deployment, it will automatically create replica sets and pods. So I just need to create the cluster. I've already done that. I need to create a deployment. That's step 2. And then I need to create a service. That's it. I don't need to create pods. I don't need to create replica sets. Deployments will create replica sets will create pods. So the first thing that you'll find here is the deployment manifest, a file that states, what do you want to start? I want to start this specific, this is wrong. This should be Nginx. It says Nginx 2 over here. It should be Nginx. Let me create a new folder called week 28 Kubernetes and quickly start this deployment. I will also quickly go through whatever is written over here. I will create a file called, let me open it in Visual Studio Code so it's easier for people to understand. Open. There we go. I have an empty folder. I'm going to create a deployment.yaml file where I'm pasting this. What does this say? You want to create a deployment. Deployment exists in this specific version of Kubernetes API. This is the name I want to give to my deployment. I want it to start 3 replicas. All of these replicas should have these labels associated to it. This is how the deployment would know. Okay, this is my replica. This is my pod. I own this pod because it will try to check what all apps have this label associated to them. What all pods have app set to Nginx. And if you look at the template, the first thing we do here is, whatever pod you are starting, attach app as the label and set it to Nginx so that the deployment knows you are my pod. I will repeat this part. We discussed this last week as well. This is slightly important to understand. Whenever you are starting a deployment isn't something that really starts, right? It's just an abstract concept. I will start replica sets eventually, that will start pods. So you need to tell the deployment, the pods that you own, right? The pods that you are starting, they have this label. They have app set to Nginx. so that it knows कि यार 3 चल रहे हैं कि नहीं, are there 3 replicas of mine working or not. It can check कि यार does this one have app set to nginx, does the second one have app set to nginx, are there only 2 that have app set to nginx, I should scale them up and make them 3. So that is what this section over here says. Yeah, this is your selector. This is how you know you own this specific pod. And this template is कि when the pod is starting, make sure you assign app set to nginx so that whatever pods this guy starts, they have app set to nginx. The deployment knows कि I own them. If I delete this, the deployment knows कि now only 2 of them are left with app set to nginx. It will start one of them again. And lastly, the specification. Okay, yaar, this is what my containers look like. I just need one container. What is this containers? It is an array. This dash over here means it's an array. Feel free to convert this to JSON to understand this a little bit better. I want to start one container which is running. I will repeat, this should be nginx and not nginx2. And that should be exposing port number 80. This is a popular image we saw last week that just starts something on port 80. If you have this much, this is your great starting point to start your first application. All you have to do is kubectl apply -f and then deployment.yaml. If you run this, what does it say? It says deployment created. But what did we learn? Okay, if you create a deployment, if I run kubectl get deployment, one deployment has started, but a deployment starts a replica set. So if I do kubectl get rs, it tells me a replica set has also started. What else did we learn? A replica set starts pods. So if I run kubectl get pods, it tells me 3 pods are running. I just created one file. I just created one service. It started a replica set which started multiple pods. Great. My application has started. Where have I reached in the, if I go back to the original slides, I have reached this point of pods starting. I have not yet exposed them. I still need to expose them over the internet, but at least I have 3 pods running in my Kubernetes cluster. How do you expose them? You have to create a service. Let's go to slide number 5. And here on slide number 5, you will find the manifest for starting a service. Let's try to copy this over and understand what's happening here. Service.yaml. This, as you can see, says, create something called a service. Create an API, create a Kubernetes object of type service. Service was part of the V1 Kubernetes API. This is the name of the service. This is how it selects who to forward the request to. When we were starting the pods, what did we say? The pods will have app set to nginx. All the pods that we have started have app set to nginx. And in the service, we say, this will be your selector. Whenever you start exposing things over the internet, this is how you know where to forward the request. Find the pods that have app set to nginx. And lastly, it says keep the protocol using which you will be forwarding requests that are coming to you. You will be listening on port 30007. As I said, if you are using node port service, what is the type of this service? Node port. Then you have to have a very big number over here. There is a limited range of ports that you can use if you're using node port. This is why you don't use node ports and you use load balancers. And it should forward the request to port 80 of these specific pods. This is one way to create a node port service. What was a node port service? This service right here. But we don't want this. We want a load balancer service. We don't want to expose our node's IP to the world. We want to create a fresh load balancer where our service starts. And hence, we will be doing something else. We will be creating a service of type load balancer. Can you still do this? Yes, you can still do this. When you do this, You will be able to visit it. You will see the website running on localhost colon 30007. If you're running it on Vultr, you will be able to go to your IP of the node. If I go to my node, I have 2 nodes running. If I do deploy this, I can go to 65.20.69.202 colon 30007, press enter, and this will reach my pod. I will see something like this. We can try it as well really quickly. If I apply this node port service, then it will start a node port service. I can start to go to the IP of my compute, the IP of my nodes, this one and this one. Either one of them I can go to with 30007, and it will forward my requests to my Nginx pod. This is good. But what is better? If this, looked slightly better, if I could go to a load balancer IP, if I could create a load balancer. How do you create that? Very simple. Just replace node port service type with load balancer and reapply this. The good thing about reapplying it is, okay, now it understands, okay, you are changing Nginx service. It will stop the node port service. It will start the load balancer service. Based on this name, it knows that you are trying to update the old thing. And when you update it, it will delete the node port. It will start the load balancer. I've applied this. As soon as I apply this, if I go here, in a while, I will not be able to visit this specific port. And if you look at it here in Kubernetes, in load balancers, a load balancer is starting for me. I did not go to a GUI. I never clicked on the add load balancer button. It automatically started. Why? Because I told, here, start a new service of type load balancer. This load balancer runs outside your Kubernetes cluster. We discussed this last week. The load balancer that we have just started, your nodes are different that are running in your Kubernetes cluster. This load balancer runs outside. What is the benefit? Okay, I can give the user just the load balancer IP. I don't have to give the user my node IP. My node IP is hidden. In a while, whenever this starts, we can just go over here, get the load balancer IP, and visit my application. That is how we've done things until now. That is how you use services. Next slide, maybe we'll understand the downsides of services and why ingresses are better. But before we reach there, do we understand the deploying a simple application on Vultr, your own thing? Great. All right. If we understand this, then what is the downsides of using services? We will wait for this to deploy. Whenever the load balancer deploys, I can show you it will work and you can visit the website. The downsides of services are, okay, number one, if you have multiple applications, if you have a backend application, a WebSocket server, a front-end application, another application, what will you do? Will you create multiple load balancers? Okay, api.100xsteps.com, you have a load balancer for yourself, which should forward requests to the backend pods. ws.100xsteps.com, you have your own load balancer, you should forward requests here, so on and so forth. The main website, the front end, the request should go to the front end pod. This isn't great. You will have hundreds of load balancers. If you have, hundreds of services, which is very possible. Kubernetes clusters are very big. The reason it's called a cluster, the reason, this is such a popular technology is because a very big company can have multiple teams and they can all be using the same Kubernetes cluster. It can have 7,000 machines in the cluster. But you can't really create, you can create, but it's not the best idea to create 7,000 load balancers for every service that exists. Can we do better? This is where, this is the first place where ingresses help you. Second place, multiple certificates for every route or every domain name basically. Every load balancer that I have here has its own URL that is pointing to it. I will have to create certificates for them independently. What are certificates? This thing that lets you see HTTPS over here. This is a tedious process. If you've gone through the videos on certbot in 0 to 1, this is how they are created, how you have to renew them every 3 months. And it's very hard for you to remember. I have thousands of services running. I need to keep renewing their certificates every 3 months. You can still do it. As soon as this load balancer is created, why did I get logged out? Someone else trying to access my account. Maybe not. Okay. If I go to the load balancers, there is a section over here. Walter is really slow for being a cloud. There's a section over here called certificates. You can go there. You will see it lets you put your custom certificate here. You can still do certificate management. You can still do HTTPS, all that jazz. But you have to do it multiple times for every route. And lastly, no centralized logic to handle rate limiting. This is one of the biggest things here. If you have rate limiting logic, I only want to allow 10 requests a second per user. A single user should only be allowed to send 10 requests. Then I can have them individually. This load balancer will check the first one. This load balancer will check the second one. This will check the third one. I can't say all of my services combined can handle 10 requests a second. Will not take more than that from a user. Because there's no combined load balancer. What we need is a combined load balancer. A single load balancer that handles everything. If a request comes to here or here or here, doesn't matter, should go to the same load balancer, should get forwarded to the right service based on the URL or based on the path. I repeat, I want to create an architecture. It doesn't matter how complex my Kubernetes cluster is. I want a single load balancer where a request comes, and based on either the domain name, if it came to api.100xdevs.com, then the request should go to pod number 1. If it came to 100xdevs.com, then it should go to the front end pod that we have. Either based on this domain name, the load balancer should route the request, or based on the path. If request came to 100xdevs.com/API, then send it to the backend pod. If the request came to 100xdevs.com/ or 100xdevs.com/frontend or /WS, then it goes to the second pod over here. We need a single load balancer to handle all of this. These are the 3 downsides of using services. Does that mean you should never use services? No, you don't have to worry about this unless you're creating a use case like Replit. If you go to the Replit video that I have on YouTube, there we need we cannot create infinite load balancers. We need a single load balancer to send requests to user pods. There the architecture we took was every user that comes on your Replit website gets a small pod created for them. So we cannot have multiple load balancers. It's just a bad idea to have thousands of load balancers. And hence over there, it made sense for us to use something like path-based routing. If the request comes to api.replit.com/ container, some container ID, then you take this specific request and route it to this specific container that is running for the user. Only in some advanced use cases, if you have a very big company, your load balancers are getting very expensive, or you're hitting the limits of a load balancer on your cloud provider. A lot of times cloud providers won't let you create 70,000 load balancers, right? If you're reaching that stage is when ingresses come into the picture. Ingress is a extra concept that isn't ingrained in Kubernetes. I repeat, Harkirat, what are the things that are ingrained in Kubernetes? Deployment is, replica set is, pods are. Ingress is something else, something extra that you have to install in your cluster. Specifically, this thing called ingress controller is something you need to bring to your cluster if you ever want to use ingresses. The thing about Kubernetes is, if you remember a little bit from last week's architecture, I told you there is a master node and then a bunch of worker nodes. You can have multiple master nodes, multiple worker nodes, but they do different things. Worker node is responsible for actually running your pod. Master node does a bunch of orchestration. It had various parts over here. It had the API server. It also had something called the controller manager. If you remember this, controller is a very commonly used term in Kubernetes. A controller means an infinite process that keeps on running. Whenever you do a deployment, there is something that is checking, have I created the right replica sets? After I've created a replica set, there is something that is checking, are there 3 pods present or not? These are infinite loops that keep on running inside the controller manager. The controller manager runs a bunch of controllers. It runs a deployment controller. It runs a replica set controller. And what are they supposed to do? What are these individual processes supposed to do? They just keep on checking, is there some mismatch? If there were 3 pods supposed to be present on a replica set, are there 3 right now? Or are there 2? Should I start a new one or not? These are called controllers. What does controller mean in Kubernetes? An infinite process that's just running and checking state, trying to reconcile things. Ingress controller does not by default come over here. Ingress controller, you have to bring in case you want to use ingresses. And there are many popularly available ingress controllers. There isn't one. People have built very big companies around just creating an ingress controller. Nginx in ingress controller is the most famous one. Then HA proxy has one. Both of these are HA proxy and Nginx were popular load balancers, reverse proxies for a while. They only created the 2 popularly known ingress controllers today. And then there is Traffic, whose spelling I always mess up. Traefik, I think. This, I think, is a for-profit company that has created this and lets you do a bunch of things on top. These are 3 of many ingress controllers that exist. What is an ingress controller? Here, whenever you're starting an ingress, I will check, I will help orchestrate it, I will help you route requests to the right places. So, an ingress is an API object that manages external access to a service in a cluster, typically HTTP. Ingress may provide load balancing, SSL termination, and name-based virtual hosting. What is an ingress? It is this thing right here. Whenever your client sends a request to your ingress managed load balancer, you don't have to create a load balancer service anymore. Ingress manages it, creates a single load balancer for you, and any request that comes first reaches the ingress pod. There is a pod that is running, Nginx or HA proxy or whatever you are using, that is able to look at the URL and tell, you want to go to api.100xdev.com, go to the backend service. You want to go to the 100xdev.com, which is the front end, go to the front end service. So what is an ingress? If eventually, let's say I have a simple application which has just the front end and the back end. This is the cluster. This is node number 1. This is node number 2. This is my front end pod. This is my front end pod number 2. This is my back end pod. This is my back end pod number 2. This is my back end pod number 3. They don't have to exist on same machines. Just for ease of looking at it, I've done it. Now we want to say, any request that's coming on a load balancer will first go where? It will go to a pod that is running ingress, that is running Nginx, that is running HA proxy, whatever load balancing framework library you are using. The request will first go here. This guy will check, request kahan se aayi? Where did the request come from? Is it coming from api.100xdev.com? And if it is, it will be like, okay, you need to go to one of these 3 pods. But what did I say a while back? It's very hard to find the right pod. What you do is you create a cluster IP service. You create a cluster IP service, which is only accessible inside your Kubernetes cluster. We create a service, but not a load balancer service, not a node port service. We create a cluster IP service. These backend pods, this cluster IP service, whoever is sending a request there, this request will get load balanced amongst all 3 of them. And the ingress controller is able to forward request to this cluster IP service, which forwards it to one of these 3 pods. And similarly, we will have a cluster IP service for the front end as well, so that any request that's coming to 100xdevs.com, it will get routed to the front end service. So what all things do I need to create if I want an architecture like this? Kirat, number one, you need to create a deployment for the front end. Number two, you need to create a deployment for the back end. Number three, you need to create a cluster IP service for the front end. Number four, we need to create a cluster IP service for the backend. And then we need to create an ingress. Jahan pe we will write some configuration. We will write if the request comes from this domain, go here, comes from this domain, go here. So these 5 services, these 5 Kubernetes objects I need to create a system like this. Let me color code this separately. Kirat, there is also a service over here, the load balancer service. Why did you not create this? Because the ingress automatically creates it. Whenever you add an ingress controller to your cluster, you get a ingress managed load balancer. You don't have to manually create this. Do we high level understand this final architecture of a good full stack application? This application is only missing a database. Other than that, you're able to deploy a full stack application if you're using something like this. All right, we understand this sort of. Maybe we'll understand this better. 86% is great. We'll proceed. We'll understand this better when we write some code. So let's see. Let's write some code. But this is where, one very important thing to keep in mind. You cannot use ingresses unless you bring in an ingress controller. Here is a popularly available list. Let's see. Here is a bunch of available ingress controllers. Bring whatever one you like. A lot of times, companies that are for profit are building a bunch of features in there that are, that will help you, that'll make your life much easier. So Traffic is one of those companies, which is why, a lot of times you use something like Traffic over the popularly free Nginx one, because, it gives you something extra. So feel free to choose which one of these ingress controllers you want. We will be dealing with 2 of them. We'll first try to do things with the most popular one, which is the Nginx controller. And then eventually we'll try to use Traffic as well. If you know these 2, you can move on to any third one. It's fairly easy. Before we go there, one extra concept we have to learn. So, forget everything we had learned until now. Forget that we're learning about ingresses. Let's quickly understand namespaces, because if we don't understand namespaces, the next slide where we add the ingress controller will become a little bit harder. So let's quickly understand namespaces inside Kubernetes. Namespace is a pretty common concept if you've done C++. How many of you have written code that looks like this? std : cin. And then you change the namespace to be std. Then you only have to write cin. Namespaces let you, structure your files, pods, in this case pods and services better. Let's look at an example. What happens when I run kubectl get pods? It tells me that you have running 3 pods running. What if I do kubectl get pods all dash namespaces? It shows me so many pods. I don't have only 3 pods running. I have 3 pods running in the default namespace. There is another namespace, which means, when you're running kubectl get pods, we won't disturb you with it. There are a few things happening in the kube system namespace. Let them run, do their thing. You only worry about the default namespace. This is why namespaces are helpful. Okay, if every time I ran kubectl get pods, it showed me all the Kubernetes pods that were running as well. These are the pods that Kubernetes runs for its own thing, whatever it needs. If every time I ran this, it showed me these as well, my life would be very hard, which is why it says, we have a bunch of namespaces. In fact, you can run kubectl get namespaces. It will show you the 4 namespaces that you have. These 3 are Kubernetes managed. I did not create them. Kubernetes does its own things over there. The default one it gives to us, you run your pods here. We will run our pods here. Is there any logical separation? Are they running on different nodes? No. It's just a it is a logical separation. It's there's no real segregation of where a namespace ka pod is running. They can run anywhere, but logically, if you do get namespaces, it just shows you, kubectl get pods. It just show you the one in the default namespace. The biggest use case of this is when you have multiple teams, right? If let's say, as I said, people are all around the world have a very big Kubernetes cluster, and all their front end back end teams are deploying to the same cluster. Now, when I run kubectl get pods, I don't want to see the front end team ke pods. I want to see the back end team ke pods. Let's say I'm part of the back end team. So namespaces help you structure it better. Let's create two namespaces. Kubectl create namespace backend, and then let's create a front end namespace. Now, anytime you're starting a pod, or let's say you're starting a deployment, let's look at the deployment that we had. We can say, you are part of the backend namespace. In the metadata, add a namespace tag and give it whatever namespace you want it to start. By default, if you don't give it, it starts in the default namespace. But if you give it the namespace backend, and if I reapply kubectl apply -f deployment, now if I do kubectl get pods, still see them. Namespace backend. Yeah. So what happened is it did not delete my old pods. Why? Because as I said, if I change anything here, if I change replicas here, and every time I reapply deployment, if I change replicas here and reapply, it will not create a fresh deployment. It updates my old one in the same namespace. I repeat, this was my original thing. I had 3 replicas here. If I do kubectl get pods in the default namespace, I see 3 pods. If I replace this with 1, it won't start a fresh deployment and start a 4th node for it. It will just update my old deployment. If I reapply this and check the number of pods now, they were scaled down to 1. But if I change the namespace itself to be backend, or if I change the name to be something, either one of these if I change, then it will start a fresh deployment for me. It will not update my old deployment. These keys represent if you're reapplying the same file again and again, should I update an old deployment or should I create a fresh one? And hence, when I added the namespace backend here, it created a deployment for me in the backend namespace. There you go. It started pods for me. In the backend namespace, so on and so forth, you get the idea. If I want to see all the pods that are running, I can run kubectl get pods --all namespaces to see, the backend namespace now has 1 replica running. The default namespace has 1 replica running, and kube system has the rest of them. So do we get an idea? Let's look at the slides. Create a deployment, get the deployments, get the pods in a deployment, start a pod in a specific namespace, and then you can get the pods. There's one extra thing that I would love, we can go through very quickly, which is if I'm part of the backend team now, and all of our deployments have namespace backend attached to them, then I will have to do this every time. Kubectl get pods --namespace backend to get back my team ka pods. If I want to apply, not applying is fine. Applying, you don't need to specify. This thing specifies the namespaces. Even while applying, you can have nothing over here, and you can specify I want to start this in a specific namespace. But better idea is कि अपने deployment manifest में ही, in your manifest file only tell the namespace you want to start something in. The problem is now if I'm the developer, the Kubernetes developer, I have to keep doing this. These are my pods. What are my services? I have no services. What if I could change the context of my kubectl? I can be like, my default namespace is backend. What did I run? Kubectl config set context --current --namespace equal to backend. Now if I run kubectl get pods, By default, it shows me my backend namespace pods. If I do a -o-wide, or if I do kubectl describe pod, name of the pod, you will see this pod is part of where is the namespace? The backend namespace. Even though I don't have to give it an extra, dash namespace backend. You get the idea, I guess. It's straightforward, hopefully. To recap, what are namespaces? They let you create logical separations of pods and services by specifying something like this. Okay, I want to start something in the backend namespace. And then whenever you apply this deployment, then your deployment as well as your pods will start in a separate namespace. They are still running together. They're still running on various machines, but they're logically separated. The backend team can just set their context to be backend. And then you go, whenever they're getting pods, they can be like, this is my pods. I don't have to worry about the other pods. By default, the context is set to default. By default, if you don't give a namespace, everything starts in the default namespace. Do we understand this? Are we good to go? I think I complicated this more than it needed to be. Is actually a fairly straightforward concept. Look at the poll. Alrighty, 85% is great. Let's proceed. All right, with Nginx, let's take a 4-minute break. It's been an hour. I will open chat, answer questions, take a breather for 4 minutes, and then happy to continue. The things that are left is understanding the Nginx ingress controller, how to install it. Maybe one thing you can do in the next 4 minutes is please install Helm on your machines in case you were following along. I'm sure a lot of you weren't, but in case you were, even after the class, this will be helpful. Just try to install Helm on your machine. It will make installing the Nginx ingress a little bit easier. With that, I'm going to look at chat. I'll just check Q&A, I guess. Recap the Nginx ingress. I'll recap ingress completely. Just 1 second. Pods in the same node can have different namespaces. Yes, pods in the same node can have different namespaces. If I start 10 pods in one, 10 pods in another one, they will share nodes eventually. How to delete or stop a deployment. Kubectl get deployment will show you your deployment. If you want to delete it, kubectl delete deployment with the ID of the deployment will delete it. Recap namespaces. There is no match labels in app Nginx in the selector of the service, but there is in the deployment selector. Why is that? The service, if you look at it, how does it know how to find people? It is based on this specific selector. Over here, you have to match labels. It says the syntax and how it's different for deployments and services. Here, you just have to tell what is the labels that my app has. Here, you have to tell it with an extra tag over here called match labels. Okay, here are the labels that you have to add. Just the difference of syntax. All right. Let me quickly recap the 2 things that we're going to use next. The first thing is ingresses, and the second thing is namespaces. Ingresses help you do something like this. This is the best diagram that you can look at if you want to know. They create a load balancer for you. You use this load balancer to send a request to an ingress pod, which then routes the request to your specific front-end or back-end service. We had a better diagram somewhere here. Okay, if you have an architecture like this, where you want to start various front-end pods and various back-end pods, you will, number 1, create the deployment for front-end and deployment for back-end so that these pods start. Number 2, you will create cluster IP for front-end, cluster IP for back-end, so these 2 services start. And lastly, you will create an ingress. What does the ingress do? Number 1, the ingress has a load balancer that exists outside your cluster, and any request that comes here will reach the ingress pod, and from here you can forward it to the front end or the back end pods based on some rules that we'll be getting to. I stand mistaken. I repeat myself, the request coming here goes to the services that we have created, which forward them to the pods. The ingress doesn't forward it directly to a pod. That is what an ingress is. That is what we'll be creating next. And the other thing I introduced was namespaces, which basically means okay, you have a very big cluster with a lot of teams running a bunch of pods on various nodes. I repeat, a bunch of teams running many pods on a bunch of nodes. And you want to give the developers of these teams some easy way to get their pods. क्या हमारा pod क्या बता दो? तो what you can do is whenever you're starting a pod, you can attach a namespace to it. क्या these two are part of the backend team, or they're part of the backend namespace. And then another pod, if you started, you can say this is part of the front end namespace. This way, the backend team people have to simply run kubectl get pods -- namespace backend, and they will get back just their 2 pods right here. They will not get back this other pod that is actually running, but they don't want that. They don't need to see that. They will not see that if they specify here, I want everything in my backend namespace. And similarly, the front end team के जो developer हैं, they can be like, I want everything in the front end namespace. They will just get back this blue pod. They won't get each other's pods. As I showed you, in the real world, there are a lot of pods running. If you run kubectl get pods -- all namespaces, you will see there are like 20 pods running. But you don't see any of these kube system pods, right? Because they're running in a different namespace. Now that doesn't mean they're physically running somewhere else. You can completely remove this namespace section. It does help you do access control and things like these, but ignoring that, it's not like you have any restrictions on if you have 2 pods on different namespaces, they need to run on different machines or anything like that. They can intermingle, run together. There's just a logical separation. Okay? So you have various pods in various namespaces, you have various services in various namespaces, just to keep things a little bit cleaner. Why am I saying this? Why am I introducing this right before ingresses? Because now we're going to add a ingress controller to our Kubernetes cluster, which will start its own set of pods. It will come and it will be like, okay, I'm running over here. I will be the first entry point into this Kubernetes cluster. I don't want to see this ingress controller, this pod that is running. It should run in a separate namespace. Whenever you will now in the future bring in more external Kubernetes configs, whenever you're adding, the ingress controllers that I showed you, these are the popular ingress controllers. There is the Nginx ingress controller. There is the traffic ingress controller. There is the HA proxy ingress controller. These will eventually start some pods, some services, some deployments. You don't want to see them though. You're like, okay, bhai, you are an extra library. Stay hidden. I don't want to see you. So run in a separate namespace. That is why we had to learn about namespaces before we install our very first Nginx ingress controller for Kubernetes. Again, to repeat, ingresses and ingress controllers are separate things. You need at least one ingress controller that is running, and only then can you start an ingress. What is an ingress? Just like deployment is a Kubernetes object, just like pods are a Kubernetes object, ingress is a Kubernetes object, but we don't have an ingress controller by default. We have to bring in one first, and then we can do whatever we want. How do you bring in one? So here is where, as I said, these are just going to be a bunch of pods that start, which means in the end, I just need another file here called nginx ingress controller.yaml, which will have a bunch of, services that it starts, bunch of deployments that it starts, so on and so forth. In fact, if I'm not mistaken, we have this very long nginx controller file in the Replit code that exists on my GitHub. So there is a video on Replit, and here somewhere, let's see if I can find the very long YAML file that I'm talking about. There you go, ingress controller.yaml. So there is this very long file that exists. You can just copy this and apply this. What does it have? It has the same thing. It has a bunch of deployments which start something, 10 of different things it has. It's such a long file for a reason. But when you're bringing in an ingress controller, you're just bringing in something like this to your Kubernetes cluster. How can you bring it? You can either copy this whole file, paste it over here and apply this file, or you can use something called Helm. That makes it very easy for you to bring in packages like these. What is Helm? Helm is a package manager for Kubernetes. Basically, whenever you have these big things that you have to bring to your Kubernetes cluster, these long files, you can just use these thing called charts in Helms that just bring them for you. What is it doing under the hood? It is bringing a very long YAML like this and applying it to my Kubernetes cluster. So if I copy this over and run these 3 commands, Helm repo add ingress nginx, and this is the link to where my Helm chart exists, and then you update that repository and install it. If this feels, oh no, I don't understand, then feel free to just copy this. As you can see, this will start a bunch of things in the ingress nginx namespace. This has metadata which says namespace you're starting it in is ingress nginx. So you can just copy this and apply this as well. Both are fine. If I do apply this to my Kubernetes cluster, if you look at the last one over here, I do say, okay, please start it in the ingress nginx namespace and also create this namespace. Now we will just wait. Seems like it is working. It also gives you, okay, you can check the status by running this command. Let's see, do we have some extra pods running? If I run kubectl get pods, I see nothing. Harkirat, no pod is running. You to said, Harkirat, okay, this will be a pod that ingress controller starts. Where is this pod, Harkirat? It is of course in a different namespace. If I do kubectl get namespaces, I will see a fresh ingress nginx namespace that has been created. If I do kubectl get pods dash namespace nginx ingress, I see a pod running over here. This pod is this thing right here. I was able to create a load balancer also. Harkirat, where is the load balancer? How do you get the load balancer? I will check kubectl get services in this namespace, and can you see there is a load balancer that is created. Harkirat, so your Vultr now has a new load balancer. Yes, it does. If I go to vultr.com now and go to the load balancers section, you will see this one has just started to be created. This is this ingress managed load balancer that I just started. And this pod that I just showed you is the pod where the first request from this guy will come. Now we have to actually write the logic to route it to the right service. But we've been able to create a load balancer in this. What have we been able to create by using Helm, by running these 3 commands? We've been able to create this part of our architecture. We still have to tell ingress the rules. Okay, this is how you forward requests. But at least you are able to create the infrastructure required for it. Why are we doing this? Because of the downsides in load balancers that we discussed a while back and why ingresses came into the picture in the first place. The next thing we have to do after all of this deployment succeeds is, something like this, same thing that I showed you on Accelerator a while back. Something like this. This is a cleaner architecture of it. A request that comes to, let's say, kubernetes.100xdevs.com/apache, or if it comes to kubernetes.100xdevs.com/nginx, notice the URL is the same. I don't have to create separate load balancers. Same URL, different route. If a request comes, it should first go to the nginx controller node load balancer, then go to my ingress pod, which should forward it to, the right service based on this route. This is the logic that we're adding next. Is it too difficult to do? No, it's fairly straightforward. You have to create this thing right here. A new Kubernetes resource called ingress. We have created deployments until now. What was the architecture? What did I write here? We have to create 2 deployments. We have to create 2 cluster IP services, and then we have to create an ingress. Deployment, if you look at it, fairly straightforward. We are creating a deployment that is going to run the nginx alpine image. Container port, it exposes it on his port 80. And then I'm starting another deployment, which is going to run this HTTPD image, which also exposes a simple HTTP server on port 80. So I'm starting these two different deployments. I am attaching a service to them as well. Okay, you are going to be attached to anything that has app:/nginx. You are going to be exposed on port 80. You will forward the request to anything that's running on port 80. This is a cluster IP type. This is a service that is only accessible internally. This is not node port. This is not load balancer. And the same thing I will do, of course, for the Apache app. Here you are also exposed on port 80 for anything that has app set to Apache. When I'm starting the pod, I'm saying you're starting with app set to Apache. The only extra thing, the new thing we're learning is this. Okay, we need to now start an ingress. This is the metadata for the ingress. I want to start it in the default namespace. Kirat, why are you starting in the default namespace? This should be in the nginx namespace. No, this is my deployment. I want to see this. This is my ingress. I want to see this in my dashboard. I want to run the commands to see its status kya hai. So I want to start this in the default namespace. I add an annotation over here. This is sort of important. Whenever you're starting ingresses, or we'll see more services like this in the future, you can change some data in there. You can talk to them by using these annotations. The annotation that we are using is nginx.ingress.kubernetes.io/rewrite target. Where can I find this? You can just go through the ingress controller documentation for nginx. It will show you this. Why are we writing this, Harkirat? Because we want any request that's coming to /Apache over here should go to the / path over here. I repeat, just because the request came on /nginx over here doesn't mean it should go on /nginx over here. It should go to the / route, the landing page of this service, which is why I had to add this rewrite target. What does it say? Request I jahan se, that is fine. It is going to go to the / endpoint of the service. It will not go to the /nginx or /Apache endpoint. If I don't do this, it will send the request to the /nginx endpoint. We don't want that. There's nothing. There's no page there. We will see this very well in the next slide as well when we go to traffic. And there's an assignment where we have to figure the same thing out for traffic. In traffic, we will not do this. We will not use this as annotation. Then we'll see some problems, and then we have to fix this by figuring out the annotations there. The specification says here, ingress class name is nginx. As I said, there are many types of ingress controllers. We have just installed one right now. In the next slide, we will install another one. There is nginx ingress controller. There is HAProxy ingress controller. There is traffic. There was a whole list. So you tell, you are going to start, or you are going to be handled by the nginx ingress class name. In the next slide, we'll be adding traffic. We will replace this with, you are going to be handled by traffic. Rules. These are the rules that you have to follow. If the request is coming on your-domain.com, Harkirat, I don't own your-domain.com. Yes. So you will put your real domain there for example, 100xdev.com. Or if you don't have a domain, I will show you a way to, make this your-domain.com work as well. So even if you don't own this, it is fine. We'll make it work. If you do own a domain, ideally put that domain name over here. In the next slide, I'll put, kubernetes.100xdev.com or something like that over there. And these are the paths that we have to route requests on. If the request comes on /nginx, then it should go to a service that is called nginx service. If the path is /Apache, then it should go to a service that is called Apache service. What were the two services that I had created? Apache-service is the name of the first one. Nginx-service is the name of the second one. Let's apply it. Let's see if it works. And then eventually, happy to take doubts and see if it, if it's confusing or not. I have to apply 5 things. I have to apply 2 deployments, 2 services, and 1 ingress. I can either apply them individually, or you can create a combined manifest file. This has everything, all the 5 Kubernetes objects that we have to create. Deployment number 1, service number 1, deployment number 2, the thing that starts the Apache HTTP server that also serves something on port 80, service for that, and then finally the ingress that we had just created. What is the most interesting thing in this ingress? These paths that we are exposing and this annotation, which if you don't understand now, it's fine. In the next slide, we'll try to figure the same thing out for traffic. Let's copy this whole thing. Let me go back to my default namespace. Let me open this, it's easier to understand. Kubernetes context. Let me go back to my default namespace. Let me come back out of the backend namespace. If I go to the default namespace, I have something running here, get deployment. Let me delete this. This will delete the pods and everything. Now I have a clean slate. Do I have any services? Get services. I have this Nginx service, which is the Nginx. Yeah, this also I need to delete. This Nginx service is not the Nginx managed service. This is this service that I had created from this file. I can keep this as well. It's fine. I have an extra load balancer running, or I can get rid of it. Either is fine. Let's just keep it. Yeah. Oh no, we have to delete it because we're starting something with the same name. I'm going to start something with the same name right now. So let me just delete this as well. Again, I'm not deleting the Nginx managed service. That is a different one. That is running on -- namespace ingress -nginx. This is a different one. I'm not deleting this load balancer. I'm deleting this load balancer I created in the beginning of the class. It will delete deployment. Sorry, service. All right, this should delete it. Now let me add the file. Let's call it ingress-full.yaml. And here I'm going to put all the 5 of the things that I need to start. I'm going to put this very long combined manifest. Let me paste it. Again, it has everything. Let me apply it. Ingress-full.yaml. And what does it say? Deployment has been created. Service has been created. Deployment has been created. Service has been created. Ingress has been created. If I open the slides again, what were the 5 things we were supposed to create? We were supposed to create 2 deployments, 2 services, and 1 ingress. That is exactly what we have been able to create. Let's wait for it to start. If I look at kubectl get pods, I'm sure they're taking their time. Oh, they are running. So cool. If I do kubectl get services, we have 2 cluster IP services that we have just created. So I think we're good to go. What's the one thing that's missing now? Okay, our rules state only if a request comes here, should you forward the request. Otherwise, you shouldn't. I cannot go to the IP. I cannot go to some random domain name. I need to point this to my server. How can I do that? Does anyone know this already? We've discussed this once in the past. You can actually spoof domain names locally. What is a domain name eventually? If I ping google.com, it's just an IP under the hood, right? We find this IP from a DNS server. If I ping your-domain.com, it is also an IP that exists somewhere. Someone else owns this. But I can tell my machine, you will point to this IP. This is how people spoof google.com. You can get your friends' credentials, create a fake google.com, show it to them. You can on your machine say, this domain will point to my IP, mere server ki IP. So you can open this file called sudo v/etc/hosts. Now on Windows, this might be something else. On most Linux-based machines, you'll find it here. Sudo v/etc/hosts, and then add whatever entry you want. For example, I want your-domain.com to point to what? To my ingress controller load balancer. If I go back to Vultr, I have 2 load balancers. Now it will be very hard for me to tell. Oh, I guess we just deleted the other service, so we should now only have 1. If I open this and copy the IP, this IP right here, and paste it in my local hosts file, I am telling my machine, my Mac, for you to your-domain.com points here. Doesn't matter what the DNS server says. For you, this server points to this IP. Why is this good? Because I can test this locally without actually buying a domain. So if I copy this, if I now ping your-domain.com, what does it say? 65.20.78.126, which is my load balancer's IP. Even though I don't own that domain, I was able to, on my machine at least, spoof it to point to my own server. Now if I go to your-domain.com/Apache, seems like it goes to the right URL. If I go to /nginx, seems like it goes to the nginx pod. So were we able to create an architecture that looks like this? Any request that's coming to your-domain.com/Apache is getting forwarded to the Apache server. If it's coming to /nginx, it is getting forwarded to the nginx server by creating, a very long manifest which starts these 5 things. deployment, 2 deployments, 2 cluster IP services, and 1 ingress. We good to go, guys? Let's do a poll. Let's understand, do we understand ingresses? If you understand ingresses, then we'll just try the same thing for traffic, which is another ingress controller. We can skip this as well, we can try this for as many ingress controllers. We'll do the same thing in the end, so it doesn't really matter. We don't understand 76%, 70%. All right, we will open chat and we will answer some questions now. Any questions I can help answer? Let's open chat. Annotations. That's a great question. What else? How to spoof the domain. Okay. Let's say we don't spoof the domain. Let me do this even easier. Let me replace my deployment with not yourdomain.com, but class 28.100xdeps.com. This to I own, right? This to domain name Harkirat owns. I can replace this Nginx rules with this. I can tell it reapply. And now I can point class 28.100xdeps.com to my load balancer. I can go to Google Chrome, domains.google.com, where I've bought this specific domain from. I can go to 100xdeps.com, click on manage, go to this DNS section of 100xdeps.com. As you can see, I have a bunch of them. I have backend 2.100xdeps.com pointing somewhere, backend 1.100xdeps.com pointing somewhere. I can add another entry here. I can say manage custom records. Add a new record. Class 28.100xdeps.com points to my Walter IP, which is this thing right here. Save. Type is A. Now this might take some time to deploy. And now everyone can test this. You can test this on your side as well. If you go to week28.100xdevs.com/Apache, it did not work because the DNS takes time to propagate. Let's ping. Yeah, as you can see, it says unresolved host. It will take some 5 minutes, 10 minutes. Whenever it does resolve, whenever this ping begins to work for me, is when we know, okay, you can test this directly over here. So you don't have to spoof domains. You can do it, but for this specific application, you don't need to. Annotations. In the end, we might have to specify 10 different things. For example, if a request is coming to /nginx/API/v1/user, I want the actual request to reach the pod on /API/v1/user, right? I don't want मेरा जो express server है, my express server doesn't know कि the request is I need to handle a request on /nginx. It just needs to know I need to handle the request on /API/v1/user. So since we have written such a complicated architecture, kubernetes.100xdeps.com/Apache/anything should reach this, we might have to strip off this first Apache, right? We might have to strip off /nginx before it reaches the actual thing. To do complicated things like these, another thing you might have to do is rate limit. As I said in the first slide, what were the downsides of services? Okay, you cannot rate limit them. Each service is independently rate limited. What if I want to add a rate limit now to my global load balancer? I was able to create a global load balancer. This guy right here, I want to give it here only 10 requests per second per IP. These are things you can describe in your annotations section. Nginx./requests per second is 10. Things like these. This annotation section lets you describe a bunch of annotations, which means a bunch of things you want to tell to the final Nginx controller. These are the rules you have to follow. One such rule that we added is if any request comes to, doesn't matter where the request comes, /Apache/Apache/1, you have to rewrite the final target to be /. The final request should reach the pod on the / endpoint. That is what this annotation does over here. If I remove this and retry it, you will see some problems. We'll see this in the next slide when we reach the traffic controller. So that is what an annotation is. Let's see if we have more questions. In Windows, I have no idea how to change the annotations, unfortunately. Google it, how to spoof domain name. You'll find something. If ingress load balancer is outside of the cluster, then where does the ingress load balancer run? In a separate EC2 instance, completely out of the Kubernetes cluster? Yes, it runs not an EC2 instance, but yes. there is a separate machine that is running your external load balancer. That is correct. It is an external load balancer. This is something not just true for ingresses. This is true generally for load balancer services. Last week also we discussed this. Here, that is running outside the cluster. If you have a load balancer type of service, it will create a fresh load balancer. It will run outside your Kubernetes cluster. What to put in public subnets? What is private subnets? What to put in public? What controls which deployment to go where in EKS? So what controls which deployment? I'm assuming you mean which service. What controls which deployment go where in EKS? Is your question what controls which pod goes on which node in EKS? If it is that, then that is decided by the kube scheduler. If you go back to slides from last week, in the master node, if that is your question, that you'll find the answer there. Here in the architecture section, there is a kube scheduler that runs on a master that decides which pod should the node get assigned to, which node should the pod get assigned to. If that was a question, I'm sure that was a question. Is it worth deploying my front-end application by Kubernetes in terms of cost and effort? No. Kubernetes is something you should definitely not use for front-end, generally not use for a long time. If you have a very big company, a bunch of microservices, only then it makes sense. Generally, no, avoid it. It's just over-engineering at its peak if you're trying to use Kubernetes for use cases where you don't need them. Cool. Let's do another poll. I haven't explained too much since the last poll, but let's see if we're feeling better with some conversations and time. Let's do another poll. If it's above 80, close to 85-ish, we will proceed. Else, I'm happy to take more questions and, answer more doubts, even though, oh, yeah, nothing changed. All right, we will take a pause. It's at 80%. Good, not great. Let me look at Q&A next. Let me answer a few more questions to people who know everything, like 80%. If you were trying out, you can try out / read about this traffic controller quickly. I'll probably skip this for the slides now so as to move on to the things that come after. But yeah, this is just another ingress controller. For example, as I said, there are many types of ingress controllers. Traffic is another popular one. So this just shares the steps of how can you install traffic. This will start another load balancer, and how can you then create an ingress which has class name set to traffic, and this is how you create the rules for that. Pretty much does the same thing. The only thing that's missing here is the annotation. The annotation that Nginx had, we don't have in traffic. What problems does it create? Why do you see, 404 not found on /Nginx when you go to traffic? That is the assignment for this week. Can you figure it out? Take 5 minutes to do that until I answer these questions from Q&A. Can you explain the difference between ingress and ingress controller again? Let's see. Where is that slide? I want to this. Ingress is a concept. You can create, it's an API resource in Kubernetes. Too many jargon I threw at you. Ingress is something you can create over here. Okay, I have something of type ingress. You cannot create an ingress controller. You can create an ingress. You can't create an ingress controller over here. Just how you can create a deployment. You can't create a deployment controller. Then Harkirat, what is the deployment controller? The deployment controller is something that runs on this is your Kubernetes cluster. This is your master node. The deployment controller, the thing that controls the deployment, that understands, do I need to update a replica set? Is there a new deployment that has happened? Is an infinite loop, is a process that runs on this master node. Similarly, ingress controller is a similar process that will check, have you made updates? Do you want to push a new config? What if I want to change this from this to, I have a third path that is of type /backend3, which does something. There needs to be something that propagates these changes to the actual pod that is running, to the actual handler over here, this handler. Ingress controller lets you do that. Now there are various implementations of it. Nginx is a great, what does this have to do? What was ingress? It's a load balancer, right? It's an internal load balancer. It takes a request based on some path rules, header rules. It forwards it to some service. There are many popularly available load balancers. So Kubernetes folks said, why restrict ourselves to one implementation? Why do we restrict ourselves? Agar load balancer banana hi hai, if you want to make a load balancer like this, Let's let people do it. Nginx is a great team, they will do one. HA proxy is a great team, they will create one. And the developer can decide what ingress controller to use. If you look at the ingress definition over here, it says, you are going to use the Nginx ingress controller. This is which, under the hood will run Nginx over here, which is a popular load balancer / reverse proxy. But if you want, you can switch over. You can be like, nahi, I don't trust the the Nginx guys. I'm going to go with a different ingress controller. So you can find a different one over here. HA proxy is probably a better one. You can install it there. You don't have to change your final code based on your controller. You just have to change this one line over here. Okay, I'm going to use traffic now, or I'm going to use HA proxy. That is why it is good to have this segregation. Ingress controller 100 people can create. The developer needs to create an ingress resource and just describe which controller do you want to use based on whatever you have written over here. The request would, go to the Nginx ingress pod or a different ingress pod. If I open Visual Studio Code and show you kubectl get pods in the Nginx namespace, you will see a pod is running. This pod is currently handling my requests. But if I change this class name to, something else, let's say traffic, then, it will start to go to the traffic pod. Now we haven't installed traffic as the ingress controller yet, which is why this won't work. But if we go to slide number 12, that is exactly what we were supposed to do over here. If I run these commands, it will start another ingress controller in the traffic namespace. So it's a great question. That's probably a very good fundamental question. Okay, what is the difference between an ingress controller and an ingress? An ingress is a resource that the user creates. An ingress controller is one of many implementations that can handle your ingress. Your ingress can be handled by, does it matter? No, it doesn't matter. For simple use cases like this, doesn't matter at all. If you want, basic routing, if the request comes here, go someplace else. If the request goes here, go to a different place. Then it doesn't matter if you don't have to use anyone. Just install one, forget about it. Forget that it even exists. That's what most people do. You install the Nginx controller, you forget about it. It even exists. You put your routing rules, you forget about it. So you can almost assume ingress controller kuch nahi hai. There is nothing called as the ingress controller. Just like we never really worried about the deployment controller. We just created a deployment. Similarly, we don't really have to worry about the ingress controller. We can simply create the ingress and something is managing it. That thing is ingress controller. Only you now have the power to decide which one of them you want to use. Do we now understand it? Can we do a poll, Akash? I'm going to skip this slide, but try it out. Anyways, I'm assuming a lot of you are not trying it out right now. But after the class, try this out. Try to install traffic as the ingress controller. And once you do that, you will see some problems. What are those problems? Try to fix them, so on and so forth. Still at 80%. Alrighty. I think either way we'll have to proceed. But now we're reaching some simpler concepts. I will come back here if you have any questions. Give me 15 minutes to finish some simpler concepts, and then we will answer some questions. Let's finish secrets and config maps, which is like a much simpler concept to digest compared to an ingress controller. All right. Cool. Let's get right into. If you're running Kubernetes through kind, you'll face a problem. All right. Secrets and config maps. Forget about ingresses. Hard concept to choose today. Simpler concept. Kubernetes suggests some standard configuration practices. If you're using Kubernetes, if you're going in an interview, they ask you these questions. These are the answers you have to give. You should always create a deployment rather than creating naked pods. Don't create pods without deployment. If they go down, they never come back up. You should have replica sets at the very least. You should have deployments generally. That's the right way to create pods. Write configuration files using YAML rather than JSON. I think there's a way to input JSON in the Kubernetes API as well. But YAML is the preferred format, even if it's hard to read, that's what you should use. And lastly, configuration files should be stored in version control before they're pushed to the cluster. This is important. This is what we'll be doing in the lab next week. Okay, I've been running this on my machine naked like this. Apply kar do. Apply ingress. But ideally, this code should go to GitHub. There should be a repository. And there the CI/CD pipeline that should run this apply. There should always be version control. No developer should be running them on their machine like this. So, yeah, don't do this, especially in a big team. There are also access control rules. You cannot do this. You only have read access, you don't have write access. You can't really change the Kubernetes cluster. But even if you do have access, check in your code, check in these manifest files, believe it or not. That's what DevOps engineers, Kubernetes engineers are doing. They're constantly changing these files, checking them in, which get deployed directly from there. The Kubernetes V1 APIs also exposes a way to store config of your application outside the image or pod. Generally, there's this rule of thumb that you should keep in mind. If you ever create a backend Docker image, if you're ever pushing something on Docker hub.docker.com, you're pushing your own image there, don't bake in your secrets in the image. I repeat, if you're pushing any repository over here, if there is a person who has pushed Mongo image, this should have all of your code. This should not have any of your secrets, because even if it's a private repository, it's bad practice to put your secrets directly in the Docker image. A rule of thumb is, whatever are these secrets, whatever are these configuration parameters. What does configuration parameters mean? It means they let you configure your app. If you have a Node.js application where you've written some code, the database URL there, this is a secret. You can't really put it in a Docker image. Redis URL, you get the idea. Your authentication password / your JWT secret. These are things you don't want to hard code in an image. Similarly, there are a bunch of things that are not secrets. That even if people know them, it's fine. But they are configuration parameters. A good example might be, how many database instances do you need to connect to? How often do you want to scrape metrics? If you remember Prometheus and Grafana that we did, we were scraping metrics every 15 seconds. Now this is just a number. This is not a secret. Even if you bake this in a Docker image, doesn't really matter. There's a number over here, 15. If you bake in a secret over here, your JWT secret, then it's a problem. Why is that a problem? I to have a private Docker repository. Still, it's just bad practice for your image to have any secrets or any configuration parameters. A new term I'm introducing here is config parameters. Basically means, something that lets you configure your app. Whenever you will run this image, whenever you run the command docker run image, you should pass these as environment variables. Database URL is this. And, whatever Redis URL is this. And even things that are not secrets. Poll interval is 20, something like this. So both secrets, which is, all of these things you see right here, as well as non-secret configuration parameters, things that even if they're known to the world, you should still pass them in from outside the application. What do I mean by outside the application? I mean, whenever you're starting the image is when you specify them. If you might remember, we create a .env file. Any code base that you might try to pull locally, you create a .env file first. You put your environment variables there. These variables can be of two types. They can be secrets and they can be normal standard things as well. If I go to any code base, if I go to cal.com code base, and open, their main repository, you'll see there is this top level env.example file, which has a bunch of things. Now, some of these are secrets, but a public API URL is fine. It can be public. Trying to find something that's, most of these are private things you don't want to expose, but there are some things that are public. How do you do this configuration management in Kubernetes is what secrets and config maps let you do. Let's kick things off with config maps. Configuration maps, they let you configure your application. They are not secrets. The difference between, let's just first go through the difference between both of them. There are two things we're learning, secrets and config maps. There are some key differences between them. Secrets are designed to store sensitive data, passwords, database URLs, Redis URLs, things like these. Config maps, non-secret data, configuration variables, environment variables that are not secrets. Base 64 encoding, whenever you create a secret, you have to encode it in base 64. What does base 64 encoding mean? It's just, if you take some string like this, you can encode this into base64. What does base64 mean, Harkira? It's very simple algorithm. It just makes sure all the final output has alphanumeric characters so that anyone can read it. There are systems that cannot understand some characters, then those characters don't reach that final state. Too much I said. Base64 encoder. Just go to this website, put some text here, hello world, click on encode. This text that you see on the right, this is base. Oh, oopsie daisy. Feel like there's a lag. Much better. Akash, tell me if there's a lag. This is the base64 encoded version of this. If I decode this, it'll give me back hello world. Whenever you're creating a secret, whenever you are there you go. Whenever you're creating a secret, eventually we'll just have YAML files like that. There's nothing too complicated here. Just like we had simple YAML files for deployments and services, we'll have a YAML file that looks like this. Okay, this is a config map. Your poll interval is 15 seconds. And this is your secret. Your API key is this thing. Your password is this thing. The only thing to know is this isn't plain text. This is base64 encoded. It's very easy to take a string and convert it to base64. This is very easy to decode it as well. It's encoding. It's not hashing. So you can always convert it back to original string as well. Volatility and updates. Since these things are sort of non-secrets, you don't update them very often. But a lot of times you update these secrets. You what's called cycle them. The database secret is this, and the same thing is stored over here. And in the future, if you change it over there, you change it over here as well. You keep cycling these secrets because if they ever get exposed, you want to cycle to a new one. Kubernetes features. This is the biggest difference. You can just use secrets for everything. You can just use config maps for everything. But secrets, as the name suggests, you can store them in some very secure places. If you go here on this URL that I've just pointed to, there are these cloud provider specific vaults that you can use to store your final secrets. AWS, for example, has this provider that you can basically lets you hook into more secure places. We'll probably do this eventually, rather than just storing it in your Kubernetes cluster. Versus config maps, you don't worry about this. They just exist in your etcd. What is etcd? The database that Kubernetes has in the master node. This also exists in just Kubernetes etcd in plain text. This also exists in etcd in plain text, but you can secure this, encrypt this if you want to, and you probably should, because these are secrets. You don't want them. Even if they're in your Kubernetes cluster, it's mostly fine. If you trust your developers, you can also put some rules to make sure your developers cannot access these secrets. But realistically, it's if a developer wants to go rogue, they can reach your secret eventually, and hence it's a good idea to store them externally. Cool. Too much detail already. Let's go back to config maps. How do you create a config map? How do you use it in an application? Simple stuff. Config map is easy. Secrets are a little harder, and config maps is straightforward. This is how you create a config map. You say, I want to use something from the V1 version. I'm creating a config map. This is the name of it. And these are my, non-secret things. Cache size. How long should I cache a specific key for? That's a good thing to store it. So it's not a secret. Payment gateway URL. URL doesn't need to be secret. The API key probably needs to be, but the URL is fine. Things like these. There are two types of sort of things you can store. Things that are in a single line, or you can, store a whole file as config maps as well. So, if you want to store a whole file or, multi-line configs basically, then you can use this sort of a syntax. The name of it, colon, put a or over here, and then, put your whole file after it. So if you have, for example, if you want to create a .env file eventually, then you can store your complete .env file like this in a file like key, or you can, have simple key value pairs based on however you are using this in your final application. I have created a simple express application that is going to, read all of these config variables. Or environment variables. If you look at this simple express app, hopefully this is a little familiar now. We're going back to simple Node.js code. I initialize an express application, and I say anytime a request comes to the /endpoint, initialize the these variables as process.env.database URL, process.env.cache size, so on and so forth. I also read a bunch of files. Harkiyat, why are you reading files? I thought that you can inject these secrets as environment variables. Yes, you can inject these as environment variables. You can also mount these as files. If this is a .env file that you're storing here, you can mount this .env file on your final pod. We'll see that very soon. If you look at the express code, it is getting these from environment variables. It is getting these by reading through config files. What does this read config file function do? It just does a fs.read file sync. It just synchronously reads the file and gives you back the contents. And then we finally return both the environment variables and all the files that have been read. This is a simple express application. I can run this independently. I can pass it in environment variables independently. I can run this inside Docker. I can pass it environment variables inside Docker, or I can run it in a Kubernetes cluster where I use config maps to pass in the environment variables. Let's see how you can do the third one and maybe the second one. First thing you have to do is containerize this application. Thankfully, I've containerized it for you. I've also pushed it already in a public repository. If you go to 100xdevs/env-backend, you will find this Docker image that exists on the internet, which has this code but containerized. How can you run it locally? You can do something like, you don't have to use Kubernetes. You can simply do docker run this thing. It will start the container. Or if you want to really see its power, what should you do? I'm going to kill the container. I'm going to run it. With this port mapping, okay, my machine's 3003 port points to the 3000 port of the machine, of the container, and I'm going to pass it an environment variable. Our database URL is equal to AST. Notice what were we doing in the application code? We were getting this environment variable and eventually sending it back to the user. So if I start this container with these environment variables and go to localhost :3003, you will see it says database URL is AST. So can you see how the Docker Hub image has no secrets of mine, no configuration parameters of mine? Whoever is starting the Docker image, whoever is using this container, is the person who needs to inject the environment variables. Question is, how can you do that in Kubernetes? Let me kill this Docker container. Let me open deployment.yaml and let me replace, this Nginx image with 100x devs/env backend :latest. Container port should probably be 3000. If I go back here, probably have a better deployment here. Let's read through the complete deployment. What do I have to do now? Yeah, I want to start a deployment that runs my image, but along with, if you look at this deployment, it's really big. Let's look at it. Deployment2.yaml. What does it say? It says create a deployment. This is the name for it. There is going to be one replica. These are the labels. This is the template. Spec becomes complicated now. You are starting the image 100xdev/env backend. That is fine. Container port, the port where its application is finally running, is 3000. That is fine. Environment variables. This section is complicated. Can you give simple environment variables? Yes, you can simply do key and values, whatever you want. You can do this as well. Or if you want to get them from your config maps, then you can say, here, get the value from a config map keyref. This is the name of my config map. This is the key where you should get it from. If you remember what was present at the top of this slide, let me copy this and paste it above. I created a config map. I said create something of type config map, and this is the database URL there. This is the cache size there. This is the name of my config map. If I just apply this much, let me remove everything else below. If I just apply this much, kubectl apply -f deployment2.yaml, you will see it says config map has been created. If I do kubectl get config map, it tells me an e-commerce backend config map has been created. It has all of my configuration parameters. Now if I create a deployment where I say KR the environment variable database URL will come from this ecom backend config. The key of my secret that I want is database URL. The key that I want here is cache size. The key that I want here is payment gateway URL, so on and so forth. I can pass these environment variables just how I was passing it here in Docker. How was I passing it here in Docker? -e database URL equal to whatever I wanted. How am I doing it here in my Kubernetes cluster? I'm saying, yeah, there is this config map. There's a central place where I've put all of my configurations. Just pull it from there. You'll find a database key there. That is what you have to pass in as the database URL. You'll find a cache size key there. That is what you have to pass as this environment variable. All of these I've defined here at the top when I created a config map type. This is how you pass simple environment variables. One extra thing that you can do after I pass all of these environment variables, one extra thing that's done at the end is volume mounts. KR, amongst these secrets, this application.properties, as I said, is a file, which means it's just multi-line configurations. Same for this guy, same for this guy. They're not single string colon string. You can mount these as files on your final container. What if I could write something like this, .env, and here I can write, whatever cache underscore size equal to 10 and session time is 3000, so on and so forth. What if I want this to reach a file in my final pod? You can do that for these config map parameters by using something called volume mounts and volumes. You can create a new volume, create a new volume called config volume, which picks all the configurations from ecom backend config. And then you create a volume mount on your container. Okay, this specific container has a mount to this specific config volume. I think I have a better visualization for this. Let's see if I do. There you go. What does it say? It says, okay, create a volume mount a volume to this container. Do we remember Docker mounts? Do you remember Docker run -v? Some path can be mounted to, some path inside the container. If you go to the video titled bind mounts, you will see this there. Similarly, the container that you're starting over here, you say, create a volume mount that gets everything from this, or not over here. That gets everything from this e-commerce backend config map. What is this? This is the config map that I've created here at the top. Get all the keys from there and, create files. Let's see how this looks in action, how it looks in action very soon. But this is where we've created a volume mount, which depends on this volume, which, why did I create this? Which is, dependent on this specific secret name. I think I saw too fast. Let's take a breather. तो मेरे लिए भी fast हो गया. Let's apply this. Let's see this in action. Then we'll go through this file again. Okay? Let's apply this. Let's apply a deployment and a config map. If you ignore everything, what am I doing? I'm creating a deployment and I'm creating a config map. No third thing we have to worry about. Okay? Creating a config map, creating a deployment. Of course, there are extra details here, which, ignore for now. Let me apply this file. This specific file, do we have a service for this? Oh God, we'll need a service for this as well. Deployment. Yeah, we'll need a service. Thankfully, I've created it. We also need a service to expose the deployment. Let me just show this once and then, let's pick this up tomorrow if I'm being honest. It's 9 already and I feel like maybe we can explain this better. Node port. Let's just do this tomorrow. So we have 2 more things to cover tomorrow. Config maps, secrets, and maybe this traffic controller, maybe not. That's fine. We can skip this as well. But we'll start tomorrow from secrets and config maps and go from there. Yeah, still happy to take you through it once. Basically, config maps, as I said, it's another type in Kubernetes that lets you define a bunch of these configurations. And then you can use these configurations in your final Kubernetes cluster, either as environment variables like this or as volume mounts. Let's look at environment variables first. Okay, if you start this application finally, you will see these environment variables populated in your application. So that's the easy bit. Okay, you have these environment variables in a config map, a central place where multiple applications can use this config map. These 5 we were passing in, the Express app was able to get these 5 environment variables. The other type we have is a bunch of files that we want to mount on the container. If you look at the Express code again, what was the Express code? The Express code was reading a bunch of files. Totally forgot what the Express code was. But the Express code was reading a bunch of files and finally, logging the files over here. And you can also mount these files that you saw directly on a container. What does mounting it mean? They'll be part of the file system on the final container. Your Node.js file can use them and finally log them. All right, let's do a poll and then we will do questions. We'll do this again though. We'll do this tomorrow. Secrets and config maps tomorrow. If you understood config maps, secrets are fairly similar. And then, yeah, that's actually all for today. So take care, not too bad. Alrighty. Today's class was fast. I was using the last part. If you remove the last part, which was secrets and config maps, which again we will do again tomorrow. Let's do just one last poll, then I'll open it up for questions. If ignoring the secrets part and the config maps part, everything else before, which basically just means the ingress part. Do we understand ingresses? Because ingresses are actually much harder than config maps. This should be straightforward. Do we understand at least ingresses by the end of today? Okay, decent chunk too, 88%. Great, 85%. Cool guys. I'll open it up for Q&A, which includes if you want to ask questions around secrets and config maps, that's fine as well. If you want to stick to just this thing is fine as well. All right, cool. Controllers again. What if, let the questions flow in and then I'll stop. Notes incoming, thank you. If the environment variable is encoded and set in config maps, then I can still decode it and get the original environment value for it. Yes, how are you encoding it? So it's not encoded in config maps, it's encoded in secrets. And yes, you can always decode it and get back the final value. Can multiple namespaces be created in a single node? Yes, you can have multiple namespaces in a single cluster. Namespaces are a cluster concept. They're not a node concept. So yes, you can, as you saw, I had, kubectl get namespace. We had like a bunch of namespaces over here. Controllers again, let me get to that very soon. In the environment variable, I saw a message from a moderator that said slow beach mein. Last minute items for the ends. What is that? Why have 3 people posted the same link? Any last minute items before the meeting ends? Otter.ai. Huh. Sorry, 3 people posted this. I don't know what this is. Okay. Like meeting notes or something. That's pretty cool. Oh, hello, mic testing. Ah, pretty cool. I'm not testing. Okay, let's open it up for Q&A questions, guys. Have you tried Coolify? It's pretty cool. It's Vercel's open source alternative. I have heard of one. I don't know if this is the one, but yeah, haven't tried it. Just saw one a few months ago. Did not really pursue it. Traffic's ingest controller YAML file doesn't contain the annotations like the target. That is correct. Annotation, this thing. When you route to Apache, your pod, that is what doesn't have the route like Apache. That is correct. That is the reason, right? Mohammed, that is perfect. That is exactly the reason why it doesn't work. PR review when? Probably Monday, hopefully. No, not Monday, probably Tuesday. What if load balancer service and kubectl? What if we use load balancer service and do kubectl port forwarding for local debugging? For local debugging, port forwarding is totally fine. as I said, even load balancers are totally fine. You don't need ingresses unless you have 20 services now and you want to have a single domain name. No Web3 alphas, if I'm being honest. Let's see. No, nothing I can think of. Looking for referrals, main thing, PR, right? Doesn't matter if it merged. It doesn't matter if it merged because no one's looking at it. But if it's a good PR, utna is enough. There's this guy who's a lawyer. I referred him. I don't know if he got in, but he just showed me 8 PRs, and that was good enough. None of them are merged. In the convert to monorepo issue, can we use PNPM? Preferably just use Yarn. Not all people have PNPM. What are we pursuing in Zelda project? Simple order books. There's actually a video that I already have on YouTube, pretty much the same thing. Delhi meetup 6th of July. If everything goes fine, 2 of the moderators are in Delhi trying to make it happen. But Delhi is very hard. 6th July evening is the current plan. We'll see. For every DevOps thing I can't remember and need to Google GPT command in the YAML file. Yes. Same. Us, bro. Very hard to write YAMLs yourself. Just Google, just chat GPT. Now you can just chat GPT or press tab in your Visual Studio Code. You're good to go. You should review before you apply anything, but yeah, totally fine if you press tab. Why didn't we create the Apache Nginx in separate namespaces? Depends. I mean, you can create them. There's nothing's stopping you, and your application will not change at all if you add a namespace in there. We have a very simple two application cluster right now. Like we have just 2 simple applications running, a front end and a back end, for example. So I did not, but feel free to add. Won't change anything. How super women? It's pretty good. Didn't feel a difference compared to Copilot, if I'm being honest. Should I focus on backend or full stack? Decide. My laptop hangs with Yan. Okay. I made an order book in memory in Rust, Fahad. Okay. How are they scaled? As well as data being stored in memory? It's a great question. You don't scale order books. They run on a single core on a single machine. You just hope that single core is able to handle it. You shard them. If you have 10 different order books, you will have 10 different processes running, or you'll have them running on 10 different cores, but you never scale order books. You also, a single core can handle whatever 50, 100 orders that might be coming a second, or whatever the frequency is. There is no way to horizontally scale order books. You can't even do it, and no one does it. Even New York Stock Exchange doesn't do it. That was very surprising for me as well when I learned that. Can you make videos on system design specifically for remote job interviews? Sure, but for remote job interview, okay. So it seems like no more questions around Kubernetes, and we can have a casual chat. Remote jobs system design is usually 90%, maybe more of the times I've interviewed. They ask you about the product they're building. If you interview for a wallet, they'll be like, "Acha, how would you build a wallet? Explain me everything." And they go from there. So there is no playbook to follow. They don't ask standard questions you might see everywhere, or system design thingies. They simply ask, "Okay, this is our application. How do you build it? A basic version of it." Then you ask a bunch of questions, poke a bunch of holes in your implementation. Not really cloud. Ran into issues on Kubernetes on latest macOS. I did not. But again, feel free to just use Walter. Walter is free, guys. If you put in your card, I think they give you like $200 of credit or something like that. Just use that if it doesn't run for you locally. Vishnu, okay, I remember you, Vishnu. I did message one guy. Wait, were you not connected to that guy? Someone was connected to that guy. Let me think. Akash, keep a track of Vishnu. We referred someone to that guy. I don't know his name, and I've saved his name as the podcast guy because he was part of cohort 1. We did a podcast. Just remind me. If that guy did not go in, then happy to connect you. If we bring 100x devs, you will sign at Delhi meetup certificate. Oh yeah, sure. Depends on the number of people, but if it's manageable, sure. There are many things to learn for the system design. If you can give some advice on that, there are standard things to learn. For example, how do you scale a backend? What is caching? How do you write through cache? How do you scale a database? If your number of requests are X, what will you do? How would you build a monitoring system on top of it? DDoS attack ho gaya to kya karoge? Things like these are standard questions. Then there are specific questions of that specific organization that you're joining. If you're joining a trading company, then they'll ask questions. This happened with us day before yesterday. How would you solve this? They spend a lot of time solving that problem, right? So they have a lot of context of it. They can grill you very well on it, which is why if you are preparing for a system design interview, prepare it with some nuance to that company. If that company is an e-commerce website, standard things that might happen in e-commerce. What goes down? Payment failed, what would you do? Delivery banda returned, what did you do? Delivery went to wrong place, what would you do? Corner cases like these, just keep them in mind. But first, make sure you can build scalable backend applications and then go from there. No plan for any other meetup in the second cohort, at least. I think Delhi, based on how Delhi goes, we'll see. But full eyes on Delhi right now. Where to learn about standard system design? You'll find videos on YouTube. So there is this one opinion here, contrary opinion that I have. I have never gone through any videos. I've just learned on the job. One good thing to do is you build a lot of backend projects. For example, code forces, what are the challenges here? How could you build? Like, think of it from scratch. A lot of time goes into building the system design of it rather than writing the code. That is one way. Other than that, there are standard. There is one thing that I saw. So real-time leaderboards that I was reading about recently. I reached a person. Now I don't know. I'm not vouching for him, or I don't know if he's good or bad. But he had that. At least that blog post was really good. Let's see. Yeah, systemdesign.1. Was this it? No. Yeah, this is it. So maybe this guy. I don't know. This specific blog post was really good. Oh shit! I'm not pasted it to the right place. So he has a newsletter. Probably has some I don't know, course or something. So pick and choose if you want to do it. No active recommendation, but at least for this use case, pretty comprehensive guide. In fact, I took some inspiration from this seems like a better structure than what we have in daily code. You have all the sections and subsections, so on and so forth. Alrighty. Briefly once, if it's a small one, I can. When does it end? Well, the hope was next month. We will see. Hope was next month. I was in fact planning the meetup to be like a farewell meetup, but I don't think that will happen. But we'll see. This is not a small PR, sir. Oh, making a mono repo. I saw this. And probably will be the first ones to get merged on this one whenever I get the time. Not right now, unfortunately. It's like you have to review imports, you have to test a lot. I probably will not be able to review this. Is very big a PR, like too big of a PR to review, but I can at least I need to test this a little bit more. Good time takes Solana development always is. Solana development, even EVM, if I'm being honest. But these more lower language development, you have to learn a lot of Rust to write good smart contracts. Even if you don't become a Solana developer, you'll be like 100 times better than modern stack engineers if you're doing Rust. So that's one big reason I recommend doing it. Other than that, of course, there are some companies hiring. You have to be really good if you want to be a smart contract engineer. But yeah, if you want to, join as a full stack engineer, then you don't really need smart contracts, things like these. Early, even like throughout my crypto journey, I wrote just one smart contract that got deployed. That also, the contract got deployed. We never wrote the front end for it. It never reached production. So, don't write contracts on a daily basis, not expected from an engineer. So yeah, no till lifetimes and generics. Cool. All right, any more questions, guys? Should we call it? Could you quickly discuss the system design behind a large scale link management system application like dub.sh, including analytics dashboard? Okay, this is quick first principles thinking. Could of course be wrong. I don't know. Link management system when I did this, so this specific problem is very common problem. URL shortener basically is a pretty common problem, and believe it or not, you would not believe which company asked me this, which CTO asked me this. Take a guess. Sorry, I'm just going off topic here, but take a guess which company or CTO asked me this 5 years ago. You will not be able to guess. So this was asked to me by the founder of, believe it or not, when this company was really small, like not even raised the first round. I interviewed there. Yes, and there this was asked by one of the founders. So then I knew this is a common question, and the way this is solved, at least the approach he told, which I don't know if I would take that approach, but that approach was what is the biggest problem here? The biggest problem is there will be too many requests. Your URL shortener needs to track how many times was goo.gl / some random hash called. If this is a million requests, could be a billion requests. What do you do when the request comes here? If a request comes to goo.gl / route, do you go hit your database directly and do a route count +1? That's probably a very bad idea. You don't want to keep hitting the database a billion times if a billion people are sending a request. So that's the first first principles thing that comes to mind. Okay, so this is going to get hit very fast. We want to redirect the user very quickly to whatever their final website is, let's say facebook.com. So you don't want to wait. Okay, yaar, let me update the database first and then I will redirect the user. So what can you do? The approach I took was some asynchronous system. Okay, we'll probably quickly throw it onto a queue and move on. And this queue will eventually get processed, basically batch processing. Okay, put it onto a queue, a store, a file. I did not say file because that was his solution finally, but throw this. AWS has this tool called Kinesis that lets you do something similar. Okay, you throw a bunch of data, eventually process it in batch. Okay, we create a very long file of one request happened to /route, one request happened to /this route, one request happened to this route, so on and so forth. You create this very big, let's say 50 MB file, and then you process it in once. Okay, you take this file and you find /route was hit 5,000 times, /askd was hit 200 times, so on and so forth. You make this bulk update to the SQL database. So this is the first thing that came to my mind. What he suggested was which actually doesn't sound too bad. And this might be the standard answer you'll find on websites, which was if you have your server running, run your specific server behind an Nginx container, behind an Nginx proxy. Sorry, you get the idea. Your first request go.gl /some hash reaches an Nginx container, which goes and hits the request to your actual backend through a reverse proxy, and this logs all the requests to a Nginx log file. And this is something that they've done very well. They've already written /route pick request. This thing is already very fast. Nginx already does it, so you can just keep processing this file from time to time. This is the approach he gave me. I don't know if I would do this. I would just do this. Take this specific every request that comes, log it out somewhere. It could also be in something like a log stash or what do you call it, Loki, to log everything at one place for once, and then eventually you can build on top of it. Okay, once you have that data somewhere, hitting the database should happen in batch. Basically, that's the only tough part here. Everything else for a link management system is what okay, we sign up, sign in, user comes, user creates a URL. You have to make sure whenever that request comes, the main endpoint that's handling everything, go.gl /any route is well distributed. You make sure it's available very heavily because this will be hit a lot. So this specific system needs to scale very well, and it doesn't do much. It just takes the request and probably sends back a redirect status code with the right thing. Another probably thing that should happen, if this is the database that has your final data, you should definitely cache this thing. This specific route points to this specific final URL because it can be like you don't want to hit the database too much, too many requests happening, so on and so forth. Yeah, that's pretty much it. All right. Okay, cool. Sorry, opening chat again. Why do you think learning Rust can make you person in alpha engineer, better engineer? It's just you learn a lot about memory management, not just Rust. You do C, you do Zig if you want to, but you learn these, you understand how computers work under the hood. The reason I am very bullish on learning these is not because most companies use them. Don't. Most companies have dumb engineers everywhere. Biggest companies are still written in PHP. No one cares. You can over-engineer your application as much as you want. You can be a very big engineer, but unfortunately, the biggest systems today run on extremely legacy systems. So learning them is not something that companies require, but it's something that that makes you a better engineer. Advice for shifting domains to MLOps engineer, so no idea what MLOps, or Golang dev or Java background. Golang sounds like the best one over here, if I'm like by a margin, or maybe MLOps engineer. I mean, maybe Java as well. I have no idea. I would go with Golang. Yeah, that'd be my recommendation. Like, that's what I would do. Baki, you should decide. I am studying in third year and built various projects in my stack. I'm confused what to do now. Maybe try to contribute to an open source project. If you build them in TRPC, maybe try contributing to TRPC or some other project. That's the only thing that's after that. If you build a lot of your projects and still not getting anywhere, the next step is just showing it to everyone else. Okay, you can build project by contributing to their projects. So is alpha engineer a thing? Thought calling yourself alpha is cringe. I don't know, man. Is alpha engineer a thing? I don't know. I think 10x engineer is a thing. There are people who are 10 times more productive in a company. Basically, in a company, there are like 2 engineers who do 90% of the work, and then 10 engineers who do 10% of the work. Something like that. I think that's a thing. I don't know what alpha engineer is. First time I'm hearing it. Can you review this trade engineering, any scope of improvement? What is trade engineering? Matching engine in Rust. Oh, okay, this is the one that you wrote. Let's see how different it is from the ones that I have written. Does this have a recovery logic though? Any market fill limit order. So this looks right. Okay, you have a bunch of HTTP routes. You don't need them to be WebSockets. This is how most traders do it as well, or trading companies do it as well. You get the order book, fill market order. Let's see. Asking price 1, ask price 2, price 3. What is this? Dummy list orders in order book. Fill market order. Add limit order, add limit order, add limit order, add limit order. Okay. Market order equal to order new. Okay, so anytime an order comes, you put a bunch of things on the book and then fill it. Let's see. कहाँ गया? Right, engine, order book, users, and IDs equal to setup engine and users. I think I'm a little confused. Why are you setting it up again anytime an engine is made? Is this like a dummy order book right now? Oh, those are tests. My bad. Okay, that makes sense. These are tests. What did I want to learn? Fill market order. There you go. Order book dot fill market order. Where does order book come from? Self dot get order book. Order books at exchange. Super order book limit. All right. Sorry, I'm a little interested to see this. There you go. Fill. Why is it not searching? Fill mark. Okay, there you go. Sorted orders equal to order dot order side. Ask equal to order book. Price. This looks right. We had like almost exactly like a similar for loop that you have. Let's see. Huh. Okay, this looks pretty good. Do you have you're here on chat, right? Do you have any recovery logic in here? What if the book goes down? You mentioned this in memory book, I think it is as well as so. So what happens when the process dies? If you haven't handled that yet, here is go back to our Redis video where I explain the architecture, a little bit of how do you add recovery to this. Basically what you have to do is, so this is how it happens in a few places. Okay, any request that comes to create an order is received by a REST server, then goes to, believe it or not, a Redis queue, then gets picked by a worker, like an order book worker, which is actually, holding your order book and placing the order. So whenever a request comes to, whatever, create a market order, it doesn't get processed here directly. It first goes to a queue and then gets processed here. The reason for this is this queue lets you rebuild the order book in case, this ever goes down. So do you have that already? Maybe you do, maybe you don't, I don't know. But that might be one good thing to add. That is pretty good. This is very close to how it's built in a few places. All right, decentralized fiber. Let me see if there's any important question I'm missing. What is your first freelancing platform where you started journey? TopTal. I was a little privileged that way. I got into TopTal early. But I started doing Upwork very soon as well. I'm a mobile developer with more than 1 year experience. Sorry. Okay, last question, guys. 9:20 here. With a service company and want to change soon. I know iOS are currently enjoying the kind of cohort. Can you send me some open source repos that you think you contribute to? Okay. Mobile repos. Oh God. I don't know any mobile development repos. One thing I can tell you is we're building a mobile app internally, but we're not building it using iOS or Android. We're building it using React Native. Probably not. Oh, you said you're moving React Native. Okay, makes sense. That's fine. I think it's easier to learn if you know native development. Easier to move here. Other side is much harder. I don't have any. Do have any React Native projects? React Native has a bunch of so Expo is a very, maybe that's a little too much, but Expo is a great company to be part of. The founder is extremely rich from his past whatever stints. So if you can get in, basically you can chill for life. If you can understand that, that's great. If you have native app development, probably needed there a lot. So maybe try Expo. It's very hard. I would assume. I haven't ever tried. But that is one company. If you're able to contribute well to Expo for 3 months, I think it's a very clear offer. They have a lot of money. Yeah. All right, I'll call it here, guys. Thank you for joining. I will see you guys tomorrow, where we'll understand hopefully persistent volumes and secrets and this thing that we missed today, basically, and a bunch of things tomorrow. All right, let's call it here, guys. I will see you guys tomorrow. Bye bye. I'll add that. I'm just struggling on how to work with recovery lately. Yeah, makes sense. I discussed this in that Redis class. I discussed the whole architecture. There's something called snapshotting. I discussed that. That's pretty much it. You're pretty close to what's needed. Yeah, just add that and you're good to go. All right, guys. I will call it here. Thank you guys for joining. I will see you guys tomorrow. Bye bye.